So we have one final example in section 5.2, and then we're all done with this particular section. Namely, we need to use the complement rule to find the probability that someone in our class has not seen all 8 movies. All right, so I know that there's a couple ways to do this. Please bear with me. I want to use the complement rule here in particular because I'm trying to get us to use the ideas of complements. Okay, so the probability that someone has not seen all 8 movies. Okay, now you and I know that not seeing all 8 movies is these 3 people right here, right? There are 3 columns. But bear with me, I'm trying to teach us a method here. So the way we could do that with the complement rule is we need the complement of not having seen all 8. Now I know it's a little strange, but what we want is, and it's going to be weird, you've not seen all 8 movies. It's a double negative. And double negatives in English mean that you want to make it a positive statement, right? So it's 1 minus the probability of, it would help if I used the right thing, seen all 8 movies. Does that make sense? All right, let me see if I can say it. This is the not seen all 8 movies. Let me highlight them. They're right here. And this is the seen all 8 movies. And together, yellow and blue make, you can tell where I'm going with this, right? Green, right? Okay, so they're asking about the 3 yellow ones. When they say have not seen all 8 movies, they're talking about yellow. Okay, but what we could do, I mean, we could add up the yellows. I mean, we all know that it's not too hard for a problem for this example. Okay, so you could add up the yellows. That's one way to do it. Or you could take the green, which is the 1, 30 out of 30, and take away the blue from it, and you'll automatically have the yellow that's left. Right, and that's what we're doing right down here. Okay, so let me write it out for you. We could say the probability of not seeing all 8 movies is equal to 1 minus the probability of seeing all 8 movies. Okay? This that they're asking about is those 3 columns. This, the 1, is the grand total, 30 out of 30, and this right here is the blue. Okay, so you can take the complement, the blue, away from the grand total and still get these 3 over here. Okay, now how would it work for probability? I'm fudging a little bit, of course, because I really want it for probabilities, not for the grand totals, but it would work, right? Because 1 is really 30 out of 30, right? Take away 14 out of 30, and you'd have 16 out of 30. Which we all know by looking at 1, 6, and 9 that they add up to 16 out of 30, but it said to use the complement rule, and that's how to use it for that particular example. And I know I took my time with it, but I want you to really understand how complements work for a table like this. In another sense, I could say, what's the probability of not being female for this particular example? Oh, whoops. I pressed the wrong thing. Probability of not female. Well, we all know that's 1 minus the probability of female, right? The not females are the males, right? So that would be 1 minus 18 out of 30, which in this case would be 12 out of 30. And now we know that that particular example was really easy. We could see it was 12 out of 30. But they're asking for the same thing. When you're asking for the probability of male, you're asking for the probability of not female, which is 1 minus the probability of female, right? This female and this not female are complements of each other. So you take 1 minus the female and you will have the male left. All right, I hope that helps with complements for contingency tables. We are going to work with and, the probability of 2 events happening and the overlap, right? And that's our next example and next section. And I'll see you then for the 5.3 notes.